Brilliant. Good afternoon, everyone, and welcome to this IOSH Broadcasting and Telecoms webinar on Stakes and Ladders, a safety case study. I'm Adam Elsworth, Health and Safety Manager at Openreach, and I also volunteer on the committee for the Broadcasting and Telecoms group. If you haven't already, please do take a look at the group website where you can catch up on all the latest news and events. Today I'm joined by my colleague Steve Tierney, also a safety manager at Openreach, and we're going to take you through a work at height project we've been working on. We'll be given the webinar strong focus on stakeholder management, which was a massive part of the project. In terms of my background, I've worked for Openreach for 16 years, starting in fibre jointing before moving into our health and safety team a little over 13 years ago. I know some people look at safety as red tape and clipboards, but nothing's further from the truth, right? And I absolutely love working both in this area of work and also in the telecoms industry. Steve, do you want to introduce yourself?
Yeah, good afternoon, everybody. My name's Steve Tierney. I worked for BT, or what was BT when I joined 32.5 years ago, and now Openreach. Started off as a field engineer through to field supervisor, manager, and then moved into the safety team just over 10 years ago. Worked with Adam ever since in the team. So back to you, Adam.
Thanks, Steve. If you want to load. Perfect. Thanks, Steve. So, who are Openreach? Well, Openreach builds and maintains a digital network that enables 600 providers across the UK to deliver broadband to homes, hospitals, schools and businesses. A few facts and figures about Openreach. So there's 35,091 people who work directly for Openreach, with over 3,000 vans and, over 27,126 vans. And actually we recruited over 3,000 new engineers into the business just last year alone. There's over 9 million engineering tasks carried out in the last year. And in terms of the network, there's 4.87 million poles and junction boxes with 189 million kilometres of cable. Now, a big percentage of that is overhead via poles and cables on walls. To access that, we have a range of access equipment, including over 25,000 extension ladders, largely as a driving force behind the project we'll take you through today. Have the next one, Steve. So, in terms of the subject of today, we're going to be running through the following. We'll stick a little bit to the DMAIC improvement cycle as we go through. That's the one on the top right there. So this is the define, measure, analyze, improve and control cycle, largely used in some of the Six Sigma and lean improvement programs. So we'll kick off with defining and building the project, move into measuring and analyzing the problem, improving the safe system of work, implementing the solution, controlling the change, making sure it works, and we'll make sure we've got lots of time for questions at the end. Next one, thanks, Steve. So, into defining and building the project. So, what's the background? Well, in the UK, obviously the Health and Safety Executive state that the work at height accidents remain the single biggest causes of workplace deaths and one of the main causes of major injury. It's UK legislation that all duty holders must follow the work at height hierarchy. That's the triangle up at the top right. So that's the avoiding work at height where we can, using work equipment or other measures to prevent falls where we cannot avoid working at height. And then where we cannot eliminate the risk of a fall, we use work equipment or other measures to minimize the distance and consequences should a fall occur. Falls from height actually represented some of the most serious accidents we saw in Openreach as well, working at locations like that in the bottom right-hand side. That's some of our equipment just located on the front of a row of shops there on High Street. 2 out of 3 of those falls needed time off to recover from the injuries, pushing over a month's recovery time for them. And around half of those require professional medical attention. Next one, thank you. So, what was the issue then? Well, a ladder set up as it should be, and as per our training, is a safe system of work. Right? In fact, as a company, we've been climbing ladders and telegraph poles for well over 100 years. Some of the photos on the right-hand side show exactly some of the practice over the years. But we still saw these accidents. So why? Well, in nearly all the instances, the setup wasn't quite as it should have been, or there were some external influences. So that's things like the ladder wasn't at the right angle, not in the 1 in 4. The securing devices weren't used or weren't used sufficiently. The site presented unique challenges, things like lean-tos or porches or driveways where you've had to position that ladder slightly different. The weather, right? Actually, being in the UK, the weather has a massive effect on the ability to work at height, things like muddy boots through to just strong wind and rain. And the ground conditions. Probably one of the most common causes of our ladder failures were ground conditions. So things like decking. Decking and ladders do not go hand in hand. Things like gravel and generally poor grip on the base of the ladder there. So the questions we asked ourselves, can we design out this risk, or can we reduce any residual risk that's left? And there were a number of initiatives generated off the back of that, including the access equipment we have available and how the network's installed. But today we're going to focus on a very specific part, which is the use of extension ladders. Next one, thanks, Steve. So, who's involved in the solution of this problem? Well, actually, the first thing we did was start with stakeholder mapping, and this is really important early on. We needed to understand who the possible affected stakeholders could be. Who do we need to work with internally? Those early conversations, things like budgets and training plans and sponsorship, which all actually take some time to put in place. Who do we need to work with externally, and what's industry doing? I'll come on to it in a minute, but always expanding horizons as well when it comes to this. The Mendeley matrix on the right-hand side was a really useful way of understanding where each possible stakeholder fits into the project. It's based around the sort of power or influence they have on your project and the interest or impact your project has on them. Something to consider is actually stakeholders don't always stay in the same category. As the project develops and moves through its phases, the relationship with each of the stakeholders will change. For example, at the start of our project, the sort of concept stage, engineers had a much lower interest. I mean, it might not even happen at this point. But as the project moves towards deployment, actually their interest starts to grow. So they move from that bottom left sort of monitor phase far through into the keep informed sort of category. So what kind of stakeholders did we pick up? Next one, thanks, Steve. So here's just some of the stakeholders involved in our project. It can be helpful to identify them by their part in the project, particularly if it's quite a big project like this one, you can break it down into chunks. But of course, some of the stakeholders actually will be involved in multiple parts. So here, for example, we had other safety team members. So they might be working on similar projects and safe systems of work. So while we might be looking at ladders, actually ladders might be used in other parts of the safety world. Our unions. So actually really important to get our unions involved at the start. Take them through the concept stage, explain what we're looking to do, how the systems work. Because actually, if an engineer wants to go and talk to the union about what's going on, they can have that conversation with confidence then, knowing exactly what the system's all about. Other organisations and peers, again, I'll come on to that, but really quite important in understanding, what's reasonably practicable when it comes to work at height at the moment. Other people like our customers was really important, particularly with the system we're looking at. It has a bigger impact for our customers, so we need to understand what happens to them, what would they like to know. Other people like technical experts. So our chief engineer team spend a lot of time looking at our equipment, the specifications, how it's used, what it's used for, actually spending some quality time with them to work with them and sort of develop the system and develop the components that sit within that. Trialists are really important, and it's important to get a spread of trialists across both geographies, experience, and the type of areas that they work in, the kind of work they do, but also people that will give you that really good, honest feedback and just come back and say, Adam, that bit doesn't work, or this bit does work, but it needs amending. That was vital, I think, in this project to getting a really good solution. Through to our training teams, again, massive part to play in terms of the project here. And it goes from the trainers who actually really are the face of the system, because when an engineer comes in to do their training, actually it's that trainer there that effectively sells the system to that engineer and makes a difference there between it being a success or it not working. They've got to have that confidence in how it works and that actually it's going to do its job. And that's through to even some of the training design team and the facilities. So what do we have in our course materials? How many courses do we have to change, which Steve will touch on in a minute. And lastly, through to our rollout, so our field teams, because there's a massive set of people involved in that field engineering workforce, from the engineers themselves through to their managers who are going to do the safety checks and the inspections, through to even just our rescue trained engineers. So a massive amount in terms of the stakeholders there. And the next one, thanks, Steve. So here we move into sort of measuring and analysing the problem. So something that appreciate a lot of safety professionals do is use the fault tree analysis, which was really helpful here in terms of understanding the root cause of some of the incidents. So particularly when you explain the problem, people just see it as fall from ladders. Well, it just fell off a ladder, that's the end of it. And actually really mapping that out and understanding what the root cause was between the different types of falls. So starting just even on the left-hand side where the user falls, but the ladder remains in situ. That's one type. Through to the right-hand side, where the ladder fails, which causes the person to fall. And this is where it picks up some of those common failure points I mentioned before, around things like the top of the ladder sliding sideways and causing failure, the top of the ladder coming away from the surface it's leaning against, or the base of the ladder sliding out, which was really one of the most common types of failure mode that we saw. Building this is really useful to us, but it also helps explain the issue to the key stakeholders. Here they can really understand exactly what is happening and exactly what kind of solution we might need to tackle some of these root causes. Knock on to the next one, thanks Steve. So, exploring industry. And as I said before, with this, it's not just about exploring the industry in the UK, because this problem probably isn't unique. So some of the solutions we looked at here, so you've got Steve there on the left-hand side, so he tested the Tetra system that we selected whilst working with Sky. So throughout actually our project, we've done a lot of work with Andy Moat in the Sky safety team, who really took us through how they used it, how we could apply it, and actually allowed us to test it in that safe world before taking it back into Openreach and making the modifications and tweaks for the kind of work we did. You've got the next picture along, which was another alternative system used at we tested one of our training centres, slightly different because it included ratchet straps. And again, part of the stakeholder piece, we looked at using ratchet straps, and of course, testing it with our engineers, you've got the ability to ratchet that as far as you want to go. And actually, we're not trying to break a ladder, we're just trying to hold it in place. The next one along there was actually Telstra out in Australia. So they have a system from a company called Brannock. And again, very similar type system with the rope that runs down the middle of the ladder with a effectively work restraint type approach. And we had a demo from the UK distributor of their system. And again, really interesting insight as to how someone else has approached the problem. Same type of scenario, ladders against walls and telegraph poles. And the same on the right-hand side. That's from Bell Telecom in Canada, who also incorporate a sort of safety line and harness approach, and some really interesting insights as to how the ladders are designed, the equipment works, but also in a very specific telecoms application. Really helpful, some of this, when you explain it to stakeholders, where we can go in and say, look, actually, this isn't us doing something, you know, way off piste here. Actually, this is something that is used by other telcos in the UK, and not only that, a lot of telcos around the world. Next one, thanks, Steve. So improving the safe system of work. So what I started with here actually is to take the potential solutions and then map them against the original fault tree analysis. So the risks remaining unchanged are in red. So we know there we've got to carry on the focus with the existing control measures. We've got risks that are partially mitigated in amber. So we know we've got a reduction in risk for those scenarios, but again, something we've got to keep a tight watch on the existing controls. And then the others which are significantly mitigated, which move to green. And actually these formed a large proportion of our types of falls from height. So for example, in red at the top right there, actually, you know, the system will not mitigate against something hitting the ladder. Right? So a car driving into the ladder, it will not mitigate that. So you're still going to have to keep your control measures around roadworks guarding and streetworks up to date, but actually the piece around the bottom of the ladder sliding out mitigated significantly with the system. So again, that was really helpful in terms of taking our stakeholders through to say, actually, here's where some of our root causes are, and here's what we're going to be significantly mitigated by using this solution. So at this point, I'll hand over to Steve, who's going to talk a little bit about how we involved our stakeholders throughout the project.
Cheers, Am. Thank you. Yeah, so when we first started looking at this and we sat down and obviously the engagement and the stakeholders is key, what we said was, look, what sort of message do we get out there? Who do we aim it at, and how do we put it across? Because there's going to be a significant change in the way that our engineers work. So it's going to be different type of message that, say, go to the users of the equipment, the engineers out in the field, and the managers and the supervisors who are going to be going out and doing the manager's safety checks, making sure it's being used correctly, compared to the guys that we've got teams that independently check all the access equipment every 6 months. So they're going to be different messages because everybody has a different, they're going to have a different use, a different understanding. And one of the big ones, one of the biggest ones that were out of mine and Adam's hands was sort of the communications providers. There's over 600. So there had to be some dialogue with the communication providers explaining the way that we were going to change our safe systems of work. Some of that was going to be, oh, sorry, I forgot to press the slide. So yeah, some of the communications would be sort of light touch. Some of the constant updating and regular engagement in regards to calls, meetings, etc. One of the areas that we really focused on early on was sort of the demonstration and examples. So getting some of them key stakeholders together and going through the system, explaining what it's all about. We work with management from all levels. So once Adam had got the sponsorship from Ollie Conk, our senior director, on this, it was a case of getting him to, and he's the guy on the right hand side, top picture. So that's Ollie, who was on the ladders trying out the system. Getting other senior managers involved as well, and field supervisors, getting them to understand what the system's about. And then also we did a lot of work with the trainers. So getting our lead work at height trainers to see it, to use it, to understand it. And also we needed to get the buy into it. You know, they're going to be the guys, like Adam said before, who are going to be running the training. Now, if they don't buy into it and believe in the system, then it's going to be a difficult message to get across when you're getting engineers, especially experienced engineers, who possibly are finding it harder to accept the new way of working. Also, again, the unions. So we had workshops with the unions, and that's the bottom left-hand picture where we've got some of the union as well as some of our lead engineers, patch engineers, showing them the system, getting them to understand it, because it's really key that the unions sort of get the members and support the members to use that system when we're bringing it in. What we also did as well, we worked with other safety professionals, like Adam touched on with Sky. We worked with Electricity Northwest and UK Power Networks, who've got similar systems of work as well. Went in to speak to them. How did they bring the system in? What issues did they have? Did they have to develop or change it for the way they're working and their engineers? And it's just getting that understanding and support, because it was it's still a massive piece of work. So when we went to sort of implementing the system, implementing the solution, sorry, you know, we're not all project managers, and this is a massive piece of work to 20,000 engineers. So the key thing for us was getting a really good project manager in. So we got Mike Bowen in, who's senior project manager, and what he helped us to do was break it down into a number of different categories or different systems of work with different stakeholders, and that's part of the chart that's on the right-hand side of your screen at the minute. And what that did, that gave us the chance to focus on what we could control, what we could sort of manage, and then Mike could work with the other stakeholders to get them to manage their pieces, because sometimes we get to stages where one element could be delaying the whole process moving forward. So Mike took a lot of that leadership and responsibility to move that project forward. So when we looked at, for instance, you know, what needs to happen when you've agreed the process, the training courses and the materials, you know, we had to look at what courses we have at the minute, and we had over 12 courses that had some form of ladder climbing element to it. So we had to look at all that course material. How do we change it? Do we have to bring brand new courses in? What will the effect on the times of the courses be? You know, we also had to look at all our training centres as well. So we had to upgrade each training centre where we ran training courses for ladder climbing, and we had to upgrade them so we could run this training going forward. That we've got sites all across the United Kingdom, so that was a really big piece of work with our learning and development teams. Programming the training into the training, the learning paths of our engineers as well. That was a key one. New recruits, that was pretty straightforward because they get this training as they came in and they started their induction and the journey into the company. That would all be sort of part and parcel. What we had to do then was look at our existing engineering workforce. How do we get the lines of business to focus on training their engineers? It wasn't just about sort of taking engineers out on a day-to-day basis. That would affect the work streams that for every patch. So we had to look into that and try and help them support that. Also, we had to look at the kit. Once we've got the kit in, every 6 months it's inspected independently. So how do we get that into our testing regime? How do we upskill the equipment testers to understand that kit, what to look for, how to test it, how to highlight any potential failures or end of life sort of issues that they may come across. Also, a big part of that as well was the logistics. So we're bringing all this kit in for 20,000 engineers, and from supplier through to the storage in our main distribution centre in the Midlands, then getting that kit out to the training centres, also onto the vehicles for new recruits, also getting spares in. It was a massive focus for us early on, and it was, to be honest with you, it's quite a logistical nightmare at times trying to get some of these things in place, but we got there eventually, and everything's running smoothly as we speak. Then down to, like I touched on course delivery before, with all the engineers we worked out, you need over 2,500 one-day training courses to get around the country to sort of keep up with the plan to introduce this process over the next 18 months. You know, so that was a massive focus on that, because it's not just a case of getting the training set up and organised. Sometimes with the effects of, like, we get storms, floods, you know, what we've all been through this year with the COVID, that's really knocked it back a few months in regard to our original delivery plans. So we've got to try and play catch up and get everything back on track, and move that forward. Also, a big part of that training as well is to get the feedback. Are we getting it right? How are the engineers and the trainers finding it? Is it working? So we put a big focus on end of course feedback. That was from delegates, trainers and managers that were also sitting in on the training too. We also arranged workshops, phone calls, face-to-face meetings around the country as well. There's follow-ups to try and support that development, to make sure we're getting everything right and to make any changes or take on any sort of feedback that we thought would benefit everybody going forward. Looking at the feedback, and what Adam's done here is put a slide together, and this is just a small selection of some of the feedback we received from managers and engineers. And this was following courses where people had sort of let us know what was going well, what wasn't. And to be honest with you, at times, and there's one that I highlighted in red, and this was a common bit of feedback where the system would take a little bit of getting used to. You know, it made them feel safe, but it was a total new way of working. We did have, you know, we still do at times, to be honest with you, get some feedback from engineers who've climbed ladders for 20, 30 years and they've never been in a position where they've fallen off a ladder or the ladder's failed, anything like that. It'll never happen to me scenario. But one bit of feedback I remember, and it sticks with me, is one of the early pilot courses that we had, where we had an experienced engineer, and initially he just sat there shaking his head, and he wasn't really engaging in the course and the feedback and the course itself. When we got talking to him about 7 years earlier, he'd lost his brother-in-law, who'd fallen off a ladder at the company he worked for, and he just said, you know, I get it. He said, if that had have happened, if my brother-in-law had had a system like this, the company's investing in, he'd still be here today. And he really did sort of change the attitude of some of the other engineers that was on the course that day. So that for me was a really powerful way of sort of how people's perceptions change. Okay, so going forward, we're bringing a new system in. So how do we share the information of any changes? And how do we sort of keep people up to date with developments and things like that? We're lucky we've got quite a few different channels in Openreach that we can use. We've developed a frequently asked questions that we update every couple of months, and we've brought that down into a number of sections regarding training, equipment, climbing processes, etc. So we use that on a regular basis. We have a monthly newsletter called Safe and Well, and we put articles in that, and not just about the working at height, but all sorts of health and safety sort of news that we like to get across. So we regularly put updates in the Safe and Well magazine that's produced by one of our colleagues. Workplace is a big thing in Openreach at the minute, and there's different groups, and we have got a group for text questions and answers, and this has been a really popular way of people highlighting questions or raising issues, and because it's monitored or self-policed, they do get pretty quick answers, pretty quick resolutions. We also do see a lot of feedback and where people don't like it, and it is a good way of sort of trying to put the message across. It's there, we're bringing this in for the safety of everybody who climbs ladders. We have a quarterly newsletter that goes out to everybody in Openreach called the FEN, and we regularly put articles in there as well with updates and developments. Every engineer gets the Know Your Kit guide. They can have that electronically, they can have it printed off, and that's also proved really useful. And also the bottom 3 pictures there is just screenshots of some of the videos that we've shot with our lead at height working trainer. And again, these can easily be accessed on engineers' phones, on the laptops, and these are really popular, especially if someone needs just a bit of a reminder about some of the activities that they're going to be carrying out. Okay, so I'll pass you back over to Adam, who's going to be going through controlling the change and making sure it works.
Brilliant. Thanks, Steve. And actually, yeah, really good point on the last one, actually, because I think particularly with the videos, we get a lot of feedback from people saying, I'm going to use a system for the first time in a little while. I'm in a field in the middle of nowhere or a house that I haven't got any signal. Actually, having a copy of the video down on their phone, they can just take that out, have a quick look, and we try and make them quite small, quite short snippets, so that they, things like tying the rope at the bottom of the ladder, they can take their phone out, have a quick look, they've got it there and then, the same as really what all of us would do when you're trying to do something for the first time, and you just have a quick look and see if you can find a video. So it's really trying to build those support mechanisms with our engineers in mind. The training course covers it all, but I think, some of our engineers, they just like to be able to take that away, have a look at it in their own time, and have that with them, which really helps. So on to controlling the change, or really making sure it works. So this last stage really is one of the most important, because for us, the worst thing we could have achieved is having equipment which sits in the back of the van and never gets used. So in order to control the change, and again, making sure it works, it's all about stakeholders. Again, right, reviewing that stakeholder map, is it still correct? So, things really would have changed by the time we get to deployment and sort of in-life management. So in this stage of the project, we needed much more input from our field teams. So that included passive feedback, like some of the stuff Steve's mentioned around, results of on-site safety checks and inspections, which are one insight, but also internal social media. It's a workplace that Steve mentioned there. You get some really good insight, and also you get to see some of the common questions that come up. So people will send a photo in of a scenario and say, oh look, actually I'm struggling to deploy in this scenario, and actually having that level of engagement, one, makes it very open, so every engineer can go in and have a look and submit problems, but also you start to see other engineers sharing their solutions and saying, actually this is how I use the system to tackle that particular scenario, and you get some really good practical feedback from people. So even little examples like this on screen, where you've got the pole sling on the right hand side there. It worked for about 90% of telegraph poles, but we found there was this one particular size of pole where when you wrap the sling around, the hoops didn't line up properly, and they said actually what you need is 2 more stitches in that piece of webbing so that it will tackle it. Now, we would never have picked that up in our tests because it was a very particular sized telegraph pole, but that's the kind of stuff that you get from really having those good honest feedback channels with the engineers. It's also about the active feedback, so where we see potential issues but you're not sure about it. So one of the examples there in the top middle, engineers standing on ladders, very different insight from new recruits who are climbing possibly for the first time, and again using this system and climbing for the first time, versus our experienced engineers. So for our experienced engineers, it's tackling that muscle memory, right? Where you stand on a ladder, how you climb. Bearing in mind, some of our engineers have been climbing ladders for us for well over 40 years. That's going to take some time to get used to, but we're trying to understand as well, are there some issues in there? So what we did is do some more active feedback. So we did some round tables at all levels. We did round tables with new recruits, and a lot of the feedback is around the training and how intuitive the system is. How well does the different components come together? How easy is it to understand? For our existing engineers, it's around, actually, I access this particular type of job and it's not working as it should do, or I know this particular issue has come up. So one of the ones, you see our engineer, the second photo in there, are pole testers. So we have engineers that, what they do is they go around and test telegraph poles, but they do a lot of climbing in their day, and they do a lot of climbing in rural areas across fields and various other access areas, and they wanted a more industrial backpack, one for their kit, but also to carry other tools and equipment that they can use. So we invested in a proper camping style backpack that gave them a bit more padding, a bit bigger, and protected their gear. So actually it's taking some of those niche areas and saying, actually, we need to pay a bit more attention there and make some tweaks to the system. There's other things. So one of the points there around the bottom is we have a device that clips onto the ladder that allows us to access a single story flat roof, and normally that would come with round wheels that compress when you stand on the ladder. But what we found is when you take the tension up using the Tetra system, it pulled the ladder in and the wheels had a tendency to roll away. And obviously you don't want to squash the gutter in at that point. So what Steve did was do some tests with some suppliers around alternatives, and one of them was a flat grip type foot that we could attach to the top end stability device, and actually that performed brilliantly. So it's not just about the system itself, but also how it interacts with the other components that we use. There were some other little bits around, so the bottom left there is a setup within one of our office spaces, because some of our customer service teams and some of our desk-based teams said, look, we hear about this system all the time, and we talk to customers and we get questions from people, but we've never seen it because we don't climb. And actually we took the opportunity, so that's our learning and development offices, where they do all the training scheduling. They were doing an awful lot of work around the rollout of the Tetra system and the kind of deployments that we needed. And so they said, well, why don't we just set up a little mock-up in the office so that people could see what it was, people could understand how it worked, and then that way when someone's asking them about it, they've got that level of confidence. It's not always just about the directly affected stakeholders, it's others that are indirectly affected. Okay, over to the next one, Steve. So I'd like to finish on this slide. So I start with this, getting the balance. So we get lots of pictures sent in regarding the new system, but I couldn't help but smile at this one. So it was taken a few weeks ago on an installation task. So window cleaner on the left-hand side clocked our engineer who was installing the new drop wire and just merely looked over and said, bit much all that, isn't it? Seeing our engineer in a climbing safety helmet and a harness, and obviously the ladder securing system and the safety boots and the sash line and bits and pieces. And it really just makes us smile, because actually that engineer felt differently about the scenario and looked at this understanding, the kind of training that he'd gone through, and obviously seeing the scenarios that we explain on the course. But ultimately, any safety change project's about striking the right balance. And that's particularly when it comes to understanding and involving your stakeholders, because they're always going to be key to any kind of safety change program, and you've got to get that balance right in people understanding it. Okay, so we want to move on to the next one, Steve? Perfect. So yeah, we promised lots of time for questions and answers. Hopefully we've got some answers for you there. As I said, you can submit the questions online through the Q&A button there, or our details are on the screen there. We have had a few questions in already. So we had one around, is it possible for the ladder to fall but the engineer is left hanging? So no, so the concept of the system is that the ladder is secured to the structure, whether that's a building or a pole, and then the engineer is secured to the ladder. So it makes a very solid system to stand on, and then you're secured to that. What have we got? Have you found that complacency is a big issue when introducing a new system of work? From Michael there. Steve, you got any thoughts on that one, on complacency?
I think when we first introduced this, there was a bit of uncertainty using it. Once they got used to using it, they loved it. The majority of the engineers did. Like I said, you do get some where the complacency side tends to come from the engineers who've been climbing for years, and they just do not want to go to a new system of work that they believe, and we've had this said a few times, it slows them down. You know, so you got to try and challenge them and just say, well, this is to make sure that you go on at the end of the day. You know, because that's what it wasn't, the complacency, it was the we don't want to do it because it slows us down. That was a common one, wasn't it, Adam?
Yeah, it was. I'll tell you what, let me, while we're not being distracted, let me turn my camera on, then you can see me answering the questions. There we go. Yeah, so I mean, the complacency bit is fascinating, and I think you know, you go through that whole piece around the systematic desensitization, right, where you do that task so many times that you start to scrape away a little bit, and you think, oh, I got away with that. Nothing happened that time, and then if you're lucky, when something does happen, it's only a near miss, and that resets that kind of risk appreciation. And sure, you know, when someone's doing something all the time, and it's one of the reasons why when we looked at you know, a replacement system, you've got something that secures the ladder. So you know, I think what we saw before was that you went a reasonably small way outside of the system of work, and it led to significant consequences. And I think we wanted something where, you know, if you were slightly outside the system, actually you still ended up in a safe place. But I think complacency, absolutely. I think, you know, particularly for us, I think, you know, our engineers work on their own the vast majority of the time. So if we didn't get a system that worked and that they believed in and wanted to use, they're not going to do it, right? They're out on their own. So we had to make sure that we get the buy-in, and that actually if they get issues, if they have concerns, they've got that route to feed them in, and we can really genuinely take heart of that and have a look at it. Okay. What else have we got? We've got so one from Alan Truman, around use for accessing rooftops. So yeah, in the main, we use the system for working from the ladder, but we do also use it for accessing a single story flat roof. So we use the system to climb up onto the flat roof in a safe place, and then we disconnect and move away from the ladder at that point. Great question about do we remove old or existing equipment to ensure that all staff are using the new stuff? Yeah, Steve, do you want to pick that one up?
Yeah. This was one of the ones that we had to focus on early, and we had to get a number of stakeholders involved with that. So what we had trainers taking the old kit off people at the training centres, where engineers, shall we say, weren't up for passing it over to the trainers. Then we had the managers who collected off the vehicles as well and take it off them. And then we also had another channel where the teams that are doing the 6-month inspections of kit, they were retrieving the old equipment as well. So yeah, we had 2 or 3 different channels going on at the time, and we still do, where that equipment is collected. So, and it's taken off the engineers. Stop any temptation.
No, I mean, absolutely right, isn't it, Steve? I mean, yeah, you know, if you say to people, look, here's the new system, but please don't use the old one without taking it away. Absolutely, yeah. You've got to have that route in place, because otherwise, if someone decides to use it, yeah, you end up in a sticky spot. Have you had any? So one for me and Clements here. Have you had any objections from homeowners, building owners, to placing the fixings in their building? And then also one from Sonia as well there around working with listed buildings. Really good question. Right. So I think where you've got a ladder normally and you're just leaning it up against the building, no one's got any particular issues with it. But yeah, when you say I'm going to drill a hole in your property to install it, so the way it works is it's a temporary anchor, temporary fixing that we install. So expand, you drill the hole, install the anchor point, wind that out to make sure you've got a firm, secure attachment, and then you secure the ladder to that. It's interesting. So this forms a big part of our training, actually, because there's actually quite a small part around the actual system itself. There's a large part around why we do it and the importance of doing it and the benefits of doing it. And the other part is how you have a really quality conversation with the customer, because I think, you know, the worst case is where you turn up and say, well, I've been told I've got to do it. So, you know, it doesn't really instill much confidence. But actually, when we explain to customers, and we've spent a lot of time trying to minimize the impact to the buildings. So, for example, when we run, we normally bring in a cable at height, run it down the wall. When we drill the hole to run the cable into the property, we will use the same hole to install the temporary anchor point as we do to run the cable in. Again, there's an idea from engineers, actually, not from us, but it helps with minimizing that aesthetic afterwards. So generally, no. When we have that really good conversation with customers, and we'll even explain in videos in advance to say this is how it works, this is what it looks like. We generally get a really good engagement when they understand it's for the engineer's safety. Yeah, they're generally pretty good. Working with listed buildings, that again, so we had to do an awful lot of work on that. So, for example, Openreach has done a lot of work in Salisbury at the moment for fibre deployment. A lot of listed buildings in Salisbury, and yeah, you have to work really closely on those to understand what is the impact, how are we going to operate on that building. So obviously we're installing generally cables onto that building anyway, so the system forms a part of that overall installation. But yeah, absolutely, these are all the kind of sort of periphery bits that come up. For example, if you're working on a shared house and you're working for the customer in the upper floor, and it's the customer someone in the bottom floor there that you need to drill into. Actually, how do you get that permission? So yeah, absolutely, really good point. And actually, I think we recognise that, you know, this system, it won't be the only option, right? And I think the message we've given our people is, if you can't use the system, you don't use an extension ladder. And actually, we use alternative access at that point, whether that's a hoist or a tower scaffold. So yeah, we'll certainly push alternatives where that's not workable. So let's have a look. What we got next? So how is the ladder? Yeah, do you want to touch a little bit on the anchor point itself, Steve, and maybe just some of the basics? A few questions around the technical parts of installing it, maybe the triangulation piece as well.
Yeah, what the engineers do, it's like it's an anchor bolt, and it has been tested. It's had various pull tests by the supplier done on it. So what happens is the engineer will fix the anchor bolt, and you can put it it's got to go 90 degrees from where the strap on the ladder attaches to. So that could be anywhere from ground level up to sort of waist height, that type of height. And the engineer attaches to the anchor bolt, tightens the anchor bolt. It's like a rubber body on it. So as the engineer tightens it up, the rubber body expands in the hole and gets it to grip. There's then a pull test done on that. The engineer then will attach the strap, tension the strap up, which is hand tensioned when they've got it connected up. What the engineers and some of the feedback initially was, engineers, when an engineer puts a cable into a house, a lot of the time you go from the eyeball to the top of the house, and then you'll have to sometimes run the cable along the side of the house, especially on, say, semi-detached houses and things like that. what the engineers thought of originally was that they'd be drilling a hole every 5-6 meters, but actually you've got a triangulation method, and the straps are 15 meters long, 15 feet long, sorry. So what you can do, you can attach to both sides of the ladder, 2 anchor bolts either end of the house, if you will, and then you just loosen it up, and then you move the ladder along as you're attaching your cable to the wall. So it's really adaptable. And yeah, at first it's like any new system, it's a little bit awkward to get used to, but once engineers have done it 2 or 3 times, it's easily sort of adjusted and moved along, and really, engineers use it a lot now. So I think does that explain?
Perfect. No, thanks, Dave.
Yep.
Yeah, I did see another question from Malcolm, just regards the iBolt standard. So actually, there's probably a bit of I appreciate we weren't going to go into the technicals of the system on here, because really we wanted to focus really a lot around the stakeholder management and the big change piece. But absolutely get right, the safety professionals and all of us want to know the technicals. Yeah, so the iBolt itself. So obviously, bear in mind it's designed to secure the ladder, right? So we're not designed to secure people to it. There's a different way of doing it. If we were to attach a person, obviously things like the rooftop work, and there's obviously a load of people out there that are very experienced around the rooftop anchors and things for work restraint equipment. This is solely around making sure we've got that security in place for the ladder, because as I said, the biggest part for us was that ladder sliding out at the base, right? And so when you look at sort of the HSE's guidance on that, and you've got that piece around tying the ladder in, this was for us about giving us that option to prevent that ladder sliding out. So even before this system, we used to tie the ladder to the telegraph pole. So we would have a system that had a rope that tied the base of the ladder to the pole. It was a very simple system. It was just a rope, and we ended up training people in all manner of ways of trying to remember the knots. I think it was called URAT, didn't it, Steve? Under, round, and through. Yep. Our traders will be impressed, I remember that. But actually, the concept with this system is as well trying to be able to design out some of that human error. So it's all spring clips. So as I said, when we were bringing in a lot of new recruits, you want something that's as straightforward and intuitive as possible. So actually it's just spring clips and hook eyes to hook onto. So it's not just about that iBolt as well. It's about trying to have that system where you can make as few issues as possible. But by all means, I think probably part of the webinar here is just to get people to think about that and think about the options out there. And by all means, get in touch if you want to know some of the details from us. It's not a problem. But yeah, thank you. And the last question, is the system ready for global market? Probably not a question for me. I must admit on that. Probably, as I said, if you have a look at the different options out there, I will say again, there are a lot of different approaches to this. By all means, have a look at the market. There's a number of people out there. Our piece here really is just to say, when you do that, think about that stakeholder map. Think about sort of who's impacted and what systems right for yourselves. As I said, we had, or I still do, over 25,000 ladders. So when we did that piece of work, we do it with all these kind of other things in mind. Obviously, if anyone else is looking at this, building up that map yourselves is really important. As I said, all I say is please do have a think through that stakeholder mapping piece and keep it in mind. Okay. So I can't see any other questions come in. If anyone's got any last questions or anything, by all means, please drop them in. If not, as I said, this has been a Broadcasting and Telecoms Group webinar. So by all means, if you haven't already, please do have a look at the IOSH Broadcasting and Telecoms website. You see all the news and latest updates on there. And actually, if there's any other things you want to see covered in webinars or anything to talk through, then it's opportunity to feed that in as well. Okay, I can't see any other questions. So if that's it from everybody, thank you very much for joining us this afternoon, and we will speak soon. Thank you.
Thank you.